Hello everyone, I hope you're doing well. We're well into week 2 of our distance learning, and we had a leadership team meeting yesterday, and there are a few pieces of information I'll like to pass along. Number one, in the meeting we discussed the idea of trying to standardize some of the instruction. So all of your teachers, with very few exceptions, should be using Google Classroom, Remind, and we're also going to start using Zoom at least once a week. I will coordinate with some of the other teachers. They've got a schedule we're looking at, and I will send out information to you as soon as I have that. But suffice it to say, I will be having a once a week Zoom meeting with you to answer questions, go over anything that you might have concerns about. But we'll have a set time each week. I may have 2. Again, it just depends on how the schedule pans out. But you can look for that in the very near future. Part 2, Covalent Compounds. First thing you need to know is that we're going to be looking at covalent compounds, which are always formed between 2 nonmetals. When you look at the periodic table, get your little sketch here. That's the noble gases. Remember, everything on this side of the periodic table, these are your metals, except for hydrogen, of course. And there's a little jaggedy line down through here. Those are the metalloids. So the nonmetals are all the things living up in this corner. So for covalent compounds, it's going to be 2 things, both of which come out of this corner. Always name the first element as if it is an element. The second element is named as if it was an anion, which means put an "ide" at the end of it. And the part that makes ionic and covalent really different is that we use prefixes when we're to give us the number of atoms present. For example, if I had CO2, that would be carbon dioxide. We have to use a prefix here. And that leads us to the 4th and final rule, which is we never use mono on the first one. So I would use CO would be carbon monoxide. I use mono on the second one, but I don't use mono carbon monoxide. So those are the 4 rules. Let's take a look at the prefixes. Now we went over these before we let out for this virus. So if you would please take a look at those, pause the video for a second, and see if you can jot down the prefixes. We already know one is mono. Pause the video for a second, jot down the prefixes, and then restart the video. Okay? The prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And remember, anytime we're looking at a compound, the prefixes tell us how many atoms there are. So if I have CH4, that'd be carbon tetrahydride. CF3, the carbon trifluoride. BF2, boron difluoride. C2, dicarbon tribromide. Quick little notes here. Remember, nonmetal to nonmetal. Use prefixes. And let's try these examples. There are 3 examples. See if you can name them. Again, pause the video. Try and name the examples. So, did you get carbon dioxide, phosphorus trichloride, and this one we have to put a dinitrogen pentoxide. Dinitrogen pentoxide. Note, we do not use mono on carbon dioxide. Here are 3 more for you to try. Again, pause the video, answer the questions, and when you have your answers, start the video again. And the answers are carbon monoxide, carbon tetrachloride, and carbon disulfide. Again, note, if it's 1, we do not start with mono. Never start with mono. Quick little problem here. And what is the correct answer? The correct answer is selenium dioxide. Again, no mono to start with. The di tells me that I have 2 oxygens. If you look over this simple flow chart, if we start at the beginning, binary, which is all we're going to be dealing with, so you don't have to worry about that one. If there is a metal present, then you know it's ionic. If there is no metal present, then you know it's covalent. If it's covalent, we use prefixes. If it is ionic, we do not use prefixes. And we're going to get to one other little add-on here in our next video, which will be talking about polyatomic ions. So here's some mixed review for you to take a look at. I want you to name the following. These could either be ionic, these could either be ionic or covalent. Ionic or covalent. The very first question you need to ask for each one of them is it ionic or covalent? CaF2, is calcium a metal or a non-metal is really all you have to ask. If calcium is a metal, you'll name it as ionic. Calcium is a non-metal, you'll name it as covalent. Well, obviously calcium is a metal, so we just call that calcium fluoride. K2S, again, is this ionic or covalent? It is ionic, so we name that potassium sulfide. Notice no prefixes on the ionics. Cobalt and iodine. Well, cobalt is a metal, but cobalt has multiple oxidation states, so you need to spend just a moment or two, see if you can figure out what charge cobalt has. And it's cobalt-2 iodide. Now, I'll give the old school name. We won't actually use that, but I'm showing it to you in case you run into it someplace else when you're looking up some problems. SN is tin. Tin is also a metal, so we know this is ionic. And SN also has multiple oxidation states, so you need to come up with the correct Roman numeral for that one. Give you just a moment. Again, pause the video between any of these if you're not spotting it directly. And the correct answer is tin-2 fluoride. Again, we won't use stannous fluoride, but in case I wanted you to see it, just in case you ran into it. Now, this is a variation on tin fluoride. Should spot that this one is not tin-2, but tin-4. What about OF2? Well, oxygen and fluorine are both nonmetals, so we use the covalent rules for this one, so you are going to use prefixes. So it's oxygen difluoride. Copper and iodine. Copper is a metal, so we're using ionic rules. Copper also has multiple oxidation states, so you need to spend a moment and figure out what the charge is on the copper. Once you have your answer, move the video forward. And it's copper-2 iodide, or old school name, cupric iodide. Again, another variation on copper, different oxidation state, different charge on the copper ion. This is copper-1 iodide. Sulfur and oxygen, both nonmetals, so this will use covalent names. We will be using prefixes, and the answer is sulfur dioxide. Strontium and sulfide. Strontium is a metal, use ionic names, makes it super easy. Strontium sulfide, be really, really careful. All ionics, no prefixes. That's the one thing that you will mess up on, so be really, really careful. If it's ionic, no prefixes. So always check first before you do anything else, is it ionic or covalent. And lithium bromide is this one because lithium is a metal, bromide is a nonmetal, so we have lithium bromide. This is the end of part 2. We will do part 3 very soon, which is ionic with polyatomic ions. Thank you.